Okay, we want to calculate the sides in a right angle triangle using a ratio method rather than calculating inverse sine, inverse cos, and inverse tan, going to the angle and then getting the trig formula that we don't have. You'll use this method, A, when you don't have a calculator, or B, to give you a more accurate answer. And what I would expect is if you had a question whereby you were given sine, cos, or tan in ratio form, you would use this method rather than getting the inverse sine, cos, or tan. Okay, so the method uses what we call a model triangle. And a model triangle is the smallest possible triangle with that trigonometric ratio. So in this instance, we have tan A is 5 over 12. So our ratio is 5 over 12, and we know tan is opposite over adjacent. So the opposite will be 5 and the adjacent will be 12 in our smallest possible triangle. Now what you'll notice here, or what you should notice, is that the triangle on the left is a multiple of the triangle on the right. So each of the sides are a certain multiple larger. So if I get Pythagoras, or if I use Pythagoras, and on the right hand side I get a hypotenuse of 13, when you compare the hypotenuse on both triangles, you'll see that the left hand one is 3 times bigger than the right. Because these are similar triangles, the opposite will be 3 times larger, and the adjacent will be 3 times larger also. But we're not going to do it as simply as that, because sometimes you don't know how much larger one triangle is relative to the model triangle. Okay, so let's have a look at it. So if we're given tan is equal to 5 over 12, I use my model triangle to get what sine and cos are equal to. So sine is opposite over hypotenuse, gives me 5 over 13. Cos is adjacent over hypotenuse, gives me 12 over 13. Step 1, get the other trigonometric equations or ratios. Then I go to my big triangle, and I know that on the opposite, I'd have to use sine to get that. And if sine is opposite over hypotenuse, when you rearrange it, you get the opposite is equal to 39 times sine A. Now, I already have what sine A is. It's 5 over 13. So instead of sine A, I put in 5 over 13. And now I have 39 by 5 divided by 13, which gives me 15, which is what you'd expect. The left-hand triangle is 3 times bigger than the right one. How about the adjacent? So the adjacent will involve the cos. We know what cos is. It's 12 over 13. We use the model triangle to work that out. Multiply that out and we get 26. And again, 36. And again, it's what we'd expect. That side should be 3 times larger than the model triangle. Okay, second example, and a little bit more information so that you can generalize this. Now, what I'm being given here is tan of an angle, and I'm being given the hypotenuse. In reality, you could be given sine of the angle and the opposite. You could be given cos of the angle and the opposite. You could be given tan of the angle and the adjacent. You could be given any trigonometric function in ratio form and any of the sides in the triangle, and this method will work for you. So just because I've used tan and the hypotenuse twice, please don't assume that that's the only time you can use this. Right, we know that tan is equal to 1 over 1 in this case, so the opposite and the adjacent of my model triangle will be 1 and 1. So there's my model triangle, 1 and 1. When we use Pythagoras, so we can get the hypotenuse, and that works out as the square root of 2. I don't have the square root image on this, so I just have to use root 2. By comparison, we can see that the large triangle has a hypotenuse of 20 by the square root of 2. The small model triangle has a hypotenuse of root 2, so we can see that the big one is 20 times larger than the small one. And you could get just 20 and 20 for the adjacent and the opposite immediately. But there's a method here that will work out in all cases, especially if you don't see the relationship between those two similar triangles. So let's go to the model triangle. We get the sine and the cos of b. So I should have sine of b is equal to 1 over root 2, and cos of b is equal to 1 over root 2 as well. Okay, we're going to use those. So with the big triangle, so the big triangle, again I should have sine b, but look, it's okay. The opposite will be 20 root 2 multiplied by the sine of a. But sure, I know the sine of a up at the top right hand corner is 1 over root 2. And then when we multiply the two of those together, I'll have 20 times the square root of 2 all over the square root of 2. The root 2's would cancel, and I'll just get 20, which is what we expected. The adjacent would use the cos, so we'd have 20 by the root of 2 multiplied by the cos of a, and then we put in for the cos of a, the thing on the top right hand corner, it's 1 over root 2, and it works out as 20. Okay, so right now it's time for a couple of questions for you guys.